Welcome back to the another session of the data structure. Right now we are covering the different type of operation available for the linked list. Today we are going to cover how to delete an element from a linked list if the position is given. For example, we enter the position 1, then we have to delete the first. So first case, if linked list is empty, then we have to print that deletion is not possible and we have to exit. Second case, if the position we enter the one, then we have to store the value of pointer to another pointer. For example, we make as a temp. Then we have to make the start pointer points to the next node. And we have to print the value, whatever present inside the temp pointer, it is going to be deleted. Then we have to release the memory occupied by the built-in function, that is the free function. Then we have to exit. After that, our insertion is completed, so we have to exit. Third case, that is the if we are not enter the position 1, then what happened? Any position we can enter. So for example, there are 5 elements and I enter the deletion the element of 6. So it cannot possible. For that, we have to calculate how many number of nodes present inside the linked list to check whether the position we are entering is a valid range or not. For that, we have to first calculate the number of elements present inside the linked list. So for the calculation, we have to traverse the linked list from first to once the calculation is done, then we have to check whether the position enter is the within the range or not. So if it is within the range, then only we can able to delete the node from the linked list. Otherwise, we have to print that it is out of range and we have to exit. So this is the number of cases can be possible in case of deletion any position in a linked list. So next one is the algorithm to delete an element from any position. So first step we have to follow, that is if the linked list is empty means there is no element present inside the linked list, then we have to mention that deletion not possible and we have to exit from the program. Step 2, if the linked list contains only one element, then we have to store the start value in a temporary pointer. Then we have to make the last pointer to the next node and print the data present inside the temporary node and release the memory, and then we have to exit from it. Third step, we have to calculate the number of nodes present inside the linked list. If possible, enter within the range. If the position means whatever position we are enter, if it is a valid range, then we have to go to the previous node of the position given. Make the node as a pre-node. Means we are is in the position node, means for example we enter third position, means third position is means we have to go to the second position, third position we make as a current node. Then the store the current value into a temporary pointer, store the next of pre-pointer, means previous pointer of the current node as a current node next. Then we have to release the current node. Before the releasing of the current node, we can print the value present inside that. Then we have to exit because deletion is already over. Last step is that if the position enter within not range, means for example we calculate our linked list has the length is 5 or 5 element is present and we enter the position is 8. So 8 position is not available within the our range, so we have to print that unable to delete and we have to exit. So these are the possible cases for the deletion. So let's understand how to we have to perform the operation. So if we enter, if it is linked list is empty, so simple we have to print position deletion cannot possible exit. If position is entered, if it is a position is entered, then what happened? We have to make the start pointer as a temp, then make the start equal to start next. What is the start next? It is null value. So if it is a single element present inside the linked list, otherwise what happen if this is the case? Same thing will be happen if our position enter is 1, then what we have to do? We have to we have to go to the we have to, for example, we have to make a temporary pointer, that is temp. Right now temp store the value of starting node. So whenever you store the starting node, it's point to this one. Then we have to make the start equal to start next. Start next means start value is 150. Start next is 250. Now start store which value? 250. If it store the 250 means immediately it points to this node. So now start point to this node. So start is right now move from this node to this node. So right now start is it is already connection right now. This is the start. So if this is the start, it points to this one. Then we have to print the value of temp value, that is the 11 is going to be deleted. Then we have to release the memory. Once the release of the memory is done, means now this is the starting node, this is the ending node. So this is the way we can delete the element from the position. If the position is given is 1, we can able to delete. So another case is that if we are not enter the position value, then what are the things we have to do? So if we enter any position, next one is if you enter any position. For example, I enter the position is 10. If I enter position 10, then we have to check whether it is present inside the range or not. So for that, what we have to do? We have to calculate the number of element is present inside the list or not. So for that, for example, we make the point variable is count and we store the value is 0. Then we have to traverse from this node to this node, this node, this node. So if once we traverse all the node, then what happened? Count store the value of 5. Once means how to do it. So I can store the ptr equal to start. Then I can, so this is the ptr right now points to this one. Then I can make the while ptr is not equal to null. This is the ending condition, or is not equal to last. ptr next is ptr is not equal to null. Then what happened? So ptr equal to ptr next count plus plus. So if we execute this loop, at the end of this loop, we are already able to count how many number of element is present. Once we count the number of element present inside the linked list, then what we have to check whether the position we are enter means right now 10. Position is 10, number of element is 5. So it is not within the range. So simple, we have to print it is not possible to delete. So for example, we enter the position is 3. So we enter the position is 3. So first, second, third. So this element we have to delete. So next question, how to delete? So if we make a connection from this node to this node and we release the memory, then position third element is deleted or not. So how to do it? Position we enter 3. So we have to reach the position before. So previous node of the position we have to reach. For example, I make this pointer as a pre. Now position, this one is the position we make as a current node. Or temp, for example, I make the temp. So this is temp, this is the pre. If I write down pre next, store the value of temp next, that is the 450. So if I write down temp next, then what happened? Temp is right now this one 450. So here we store the 450. So automatically connection established to this one or not? Once the connection is established, then we can print the what? Which value is going to be deleted by the temp data. Then release the memory. So it can be possible. So these are the possible cases for the deletion at any location. It can be possible. So let's do the program. So see, this is the program we have to write down to delete an element from any position of a linked list. So here, what are the things we have to do? We have to write a function to delete an element at any location. So for that, these are the header file we require. Structure we are defined. We already initialize start as well as null. So in this program, we have already added the display function as well as the insert class, because without storing the data we cannot delete. That's why we have already insert some function, then we are going to write the delete. So void delete any function name we can write down. Here I just make a position, then the function does not take any value, does not return any value. Here we define position is a variable to store the whatever position we enter. One I for the traversing from one node to another node, then we make the count is a variable to count the number of elements present inside the linked list. Then I make the counter value as a 0. So first we have to check whether the linked list is empty or not. So check the linked list is empty. The condition is start. If start equal to null, then what happened? Linked list is empty. So we have to write down printf else means list is not empty. Or we can go for if the position is equal to 1. So we can go for first position, I can write down if the position is equal to 1. Then what are the things we have to do? So before checking whether we are entering position is 1, we have to enter the position. So we have to write down printf enter the then we have to scan it. As I have already told that we should not touch the start pointer, so we have to better to recommend that we store the start value in the another pointer. So temp pointer we store the value of start. Now position is 1 means here the list is empty. This is for position. Position is 1. Now if position is 1, then what we have to do? We have to make the start equal to start next. We have to make the start equal to start next. Then we have to make the ditch. We have to print the values of how to print it. Print new line, that is which value is deleted is deleted. So value stored inside the temporary pointer. So we have to write down temp data. So once we print, then what we have to do? We have to release the memory. So we have to free temp. Here we can release the memory or at last also we can delete. It is our choice whether we want immediately or later. We do it later. All the cases is over, then only we'll do. Else means we are not enter the position is 1. Then what happened? We have to calculate how many element is present. So while temp is not equal to null. So this is the termination condition for the linked list. What are the things we have to do? We have to move from one node to another node. So we make the temp equal to temp next. Whenever we are moving from one node to another node, at that time we have to calculate also how many element is present. So calculation we are using count plus plus. So at end of the loop, it is calculate the number of elements. Number of nodes inside inside. So once we calculate the number of linked lists, then it is easy for us to check whether it is the within the range of or not. So for that we have to check if position is greater than 0 and position is less than equal to count. It means within range. If it is within the range, then what we have to do? We have to go to the perfect position. So how to reach the perfect position means previous node of the position we are entered. So first we have to store the temp pointer, that is the value of start. Then we have to make for I equal to 1, I less than position, then I plus plus previous node we store inside the pre-temp. So pre equal to temp, temp equal to temp next. So once the loop is over, we already reached the, that time we are already reached this position. So this is the pre, this is the temp. Then what we have to do? We have to make the pre next equal to temp next. So we have to write down pre next equal to temp next. Then we have to printf new line %d deleted, which value it's stored inside the temp data. Then we have to free the temp. Better we pay immediately free, then it will be easy for us. Also same the thing we will do whenever we are performing the position equal to 1 at that time also. Here also we make the same thing here. No need to do at end. At that time we will confuse. So better here we have to make the node free. Then else. So this is the range for within the range. If it is not in the range, then what we have to write down? Printf position is out of range. So we cannot delete it. So because depend upon the starting, we have to delete this one. Then we have to delete this. So in main program, we have to call the function also. So first we have to compile the program. If it is any error, we have. Then we have to run the program. So whenever we run the program, first value, then 22, and 33. Enter the position to be deleted first. 11 is deleted, yes, because we first value is 11 is deleted. Then after that we write down the printf, so it is 22, 33. Okay. So as I have already told you that we have to run multiple times. Before running this one, also we have to check the value. First one value is 22, then 33. So now our linked list consists of three elements 11, 22, 33. Position we have to enter. For example, I enter the position. So 33 is deleted. So our program is successfully running. So once again we have to run. Then we have to make the program into the menu drive program. We have to just copy the function. So this is the function we have to put inside this and we have to add the condition inside the main program. So now one more condition we have to add here. Printf, here this is the option is 6. Deletion has this one is 7. Then we have to copy the function name also perfectly, otherwise we will get error message. So switch case we have to call the function also. So we enter the pointer is to enter the value, we enter 22. Yes, we want to. Then delete at any position 6. Enter the position, I enter 1. So 22 is deleted. So we are already execute the program, got the result. I have already shown you. So this is the just complete program in PPT. So we are already done this one. This is our output we got. Thanks for watching the video.